Hi everyone, and welcome back to the Casper Association's dApp Developer Series. Today I'll be showing you how to interact with CEP-78 NFTs using Node.js and the Casper JS SDK. CEP-78 is Casper's new enhanced NFT standard that allows deployers different selections that determine their NFT's abilities right out of the box. In this video, I'll be introducing you to the new standard and its capabilities. Then we'll put it to use by writing a Node.js script that installs the contract, mints NFTs, and queries live data on them. Let's get started. We'll begin by going through the modalities offered by CEP-78 from within the official repository. You can pull this up yourself from the link in the description of this video. These modalities dictate the behavior of the NFT collection and are chosen by the deployer at the time of deployment. The first is the ownership modality, which specifies who is authorized to own the minted NFTs. With Minter, only the minter of the NFT may hold it, and it cannot be transferred. Assigned is similar in that the NFTs are non-transferable. However, the minter may decide who the owner of the NFT is to be, including themselves. Lastly, there is transferable, which is equivalent to assigned except for that the NFTs may be transferred out of the original account. This modality is required to be specified at deployment time. Next is NFT kind. The NFT kind does not affect the function of the NFTs in any way, but is just used as a marker so viewers can understand what type of asset the NFTs represent. First is physical, which references a physical object such as a house in an innovative example. Digital refers to digital assets, like digital art, and the virtual option denotes a digital representation of a real-world asset, such as a patent or copyright. This modality is also required to be defined. Next is the holder mode. This modality dictates which entities may hold the minted NFTs. One may choose only accounts, only smart contracts, or either with mixed. This modality is also required to be defined at the time of deployment. CEP-78 allows for whitelist capability natively within its smart contract. It is an optional modality, and if not provided upon deployment of the contract, it will be set to unlocked, meaning no whitelist is set. However, it can be updated by the deployer later. One may also choose to initially set a whitelist using the locked option. Next is the minting modality, which allows either only the deployer to mint new NFTs or opens minting up to the public. You can choose whichever option you'd like using the installer or public option respectively. The new CEP-78 standard now also supports the selection of the type of metadata newly minted NFTs will take. First is the CEP-78 option, which requires that the metadata conforms to the standard shown here. Similarly, the NFT 721 option indicates that the metadata must conform to that of the ERC 721 standard, example here. If raw is chosen, there is no validation performed, and the metadata will be recorded as defined by the deployer. Lastly is custom validated, which lets the deployer define their own JSON schema for which each NFT's metadata must take on. Here is an example of what that may look like. This modality is required to be defined by the deployer. Next, we have the identifier mode, which tells the contract how to reference each NFT. The deployer must choose between ordinal and hash. With an ordinal identifier, each NFT is referenced by its sequence, 1, 2, 3, etc. When using the hash option, on the other hand, each NFT is referenced by a hash of its metadata, which is defined at the time of mint. There are two caveats to using the hash option. Firstly, each NFT must have unique metadata, as otherwise two or more hashes could be identical. Additionally, the mutability of metadata must be set to immutable, which we'll go over next. This is also a required installation parameter. Metadata mutability is also definable as mentioned a moment ago, and the deployer may choose whether the metadata should be mutable post-mint or not, save the caveat with the hash identifier. This modality is also required to be defined by the deployer. Next, we have the burn mode modality, which dictates whether minted NFTs may be burned or not. This is an optional parameter, and will default to burnable if not provided. Lastly, there is the owner reverse lookup mode, which, if enabled using the complete option, allows users and client-side applications to retrieve the NFTs of an account provided an account's public key. This extends to the receipts of the mint and transfer endpoints as well. This is an optional parameter, and if not provided, will default to the no lookup option. Now that we've looked at the modalities and what they do, let's begin writing a Node.js script that installs an NFT contract, mints NFTs, and retrieves information about them. Get started by opening up a terminal and navigating to the directory you'd like to work from. I'll start from the home directory. Create a folder for your project and name it whatever you'd like. I'll name mine CEP-78-script. Navigate into this directory and clone the contract by using git clone and copying the URL. Now head into the new folder and run make prepare. Run make build contract to compile the CEP-78 contract to WebAssembly. And this is what it should look like when it's complete. Now back out of this folder with cd .. and run npm init to set up an npm environment. Now install the Casper JS SDK with npm install Casper JS SDK. Before we begin writing any code, we'll need a directory keys that contains the secret key to a funded account. Create this new key pair using the command Casper client keygen keys. This account will need to be funded, which can be done on mainnet by sending funds to the address in public key hex, or on testnet using the faucet. If you forgot how to use the testnet faucet, check out video 3 at the 2-minute mark linked above in the card. Now create a new file, index.js, and open it in an editor of your choice. I'll be using VS Code. We'll begin the file by requiring everything we need from the Casper JS SDK, and we will also use the package fs. We'll need to load in our private key from our keys directory that we just created. If you used Casper client keygen keys, then you'll get an ED25519 key. If the public key starts with 02, it'll be a SecP256K1 key, which looks like this, but we will be using ED25519. Now we'll create a new Casper client object. If you don't remember how to find online peers, you can check out video 3 at the 1-minute mark, which will be linked above. Then we can instantiate a new contract object by passing in our client. Let's begin writing the function that installs the contract. We'll write the function installContract and make sure it's asynchronous. Now we need the runtime arguments, so for this use runtimeargs.fromMap. We'll start with the collection name, then the collection symbol, then the total token supply will have 1,000 total NFTs. The ownership mode is set to transferable, the NFT kind digital. The holder mode is set to 2, which is holdable by accounts and contracts. Whitelist mode is unlocked. The minting mode is public. The NFT metadata kind is raw in this example. The identifier mode is set to ordinal, so 1, 2, 3, etc. Metadata mutability is immutable. Burn mode, we have burnable. And the owner reverse lookup mode, we'll set that to no lookup in this example. And the JSON schema is just an empty string because this is a required argument. In the event that you're using custom validated metadata, you would want to provide your JSON schema here and stringify it. Now we'll create a signed deploy object using the contract.install function. First we'll pull in our compiled WebAssembly contract using fs. Then we'll provide our runtime arguments. Then we'll provide our gas payment, which in this case is 250 billion motes or 250 CSPR. Then we'll provide the public key, just keys.publicKey, then the network name, and the asymmetric key pair to sign the deploy. Next, we'll send our signed deploy off to the network using client.putDeploy, and we can await the deployment using waitForDeploy, but this does not yet exist under the client object, however it will soon, so you can try this first, but if it doesn't work, don't worry, we'll write the waitForDeploy function in just a moment. So for now, let's go ahead and delete client dot, and I'll paste in the waitForDeploy function right here. You can go to the repository in the video's description and copy this directly. Let's go ahead and install the contract, so we can just make an installContract call, save the script, head back over to our terminal, and run node index.js. So this is a good sign. It means our deploy was executed on the network. If you'd like to find the results of the execution, you can tap into execution results, then result. For now, we can go over to testnet.cspr.live, go to your account, click the deploy hash, and check the execution status. Since our contract installed properly, we can head back over to the editor and begin writing the mint function. So just write async function mint. Now we can write the mint arguments, and in this case we just have token owner and token metadata. The token owner will be us, just keys.public-key, and token metadata will be test metadata. Now remember, we don't need to conform to any schema because we chose raw metadata for our metadata modality. Next, we need to set the contract hash so that we can mint NFTs from our contract. So write contract.setContractHash, head back over to cspr.live, go to your account, go down to named keys, and copy the NFT contract hash. Once you have it copied, head back over to your editor and paste it in. You'll remember that in installContract, we called contract.install. In this case, we'll call contract.callEntryPoint, and we'll call the mint entry point. The only other thing we'll change is the gas payment. In this case, we'll do 10 billion motes or 10 CSPR. Now we can copy put deploy and wait for deploy directly from installContract. Our mint function is now complete, so head down and replace installContract with mint, save the file, head over to your terminal, and run node index.js. It looks like our deployment has been executed, so we can head back over to cspr.live, go to deploys, and see that the mint function did succeed. Now let's look at retrieving data about our NFTs. So head back to your editor, and let's write a new function called balanceOf. Just like in the mint function, we'll need to set the contract hash. Then we'll want to query the dictionary balances within the contract. So we'll use contract.queryContractDictionary, pass in the path balances, and we'll need our account hash for this, which can be derived from the public key, and we'll want a substring 13 characters off. The reason we take these 13 characters off the front is because when we use this method to account hash string, it will return the account hash prepended with this text here, which is 13 characters long. And we don't want this text, so we get rid of it with substring 13. As you can see down here, the response data is in hexadecimal format, so we parse the integer in base 16. Let's test this out by changing mint to balanceOf and saving our file, going over to our terminal, and running node index.js. As you can see, we get 1 because we have 1 NFT minted to our account. Next, we'll write the function readMetadata that will read the metadata of an NFT given its identifier. This function is almost identical to balanceOf, except for the fact that we are using the path metadata raw and passing in 0 as that's the index of the NFT that we just minted, and we are using the ordinal identifier mode. Additionally, we don't parse the response, we just print out response.data. Let's change balanceOf to readMetadata down here at the bottom, save our file, head back to the terminal, and try it out. As you can see, we get the string test metadata. That's all for this video. If you found it useful, be sure to hit the like button and subscribe if you'd like to see more of this series. If you'd like to be notified when new videos are released, hit the bell icon below. Thanks, and I'll see you in the next video.